Interdependent proficiencies have been used in developing the achievement outcomes and are central to progression at each step of mathematics learning. In the past, the developing numerical reasoning strand has sometimes been seen as a bit of an add-on. For example, teaching the content first and then some tasks at the end to develop reasoning and for working mathematically. The aim of the proficiencies is to have a greater integration of the what and the how. They provide a framework for discussing the knowledge, skills and experiences that constitute mathematical proficiency. Conceptual understanding of why the mathematics works and its connective nature is critical. Learners with conceptual understanding know more than isolated facts and methods. As they experience increasingly complex mathematical ideas, concepts should be built on, deepened and connected. Learners demonstrate conceptual understanding through being able to explain and express concepts, find examples or non-examples, and by being able to represent a concept in a different way, flowing between different representations, including verbal, concrete, visual, digital, and abstract. Communication with symbols lies at the heart of mathematics. Use of the symbol system to express, read, and interpret mathematics is essential, especially as we move into a digital age. Learners should understand that the symbols they are using are abstract representations and should develop greater flexibility within the application and manipulation of an increasing range of symbols and understanding the conventions of the symbols they are using. Strategic competence involves formulating and solving unfamiliar problems. Learners should have a toolkit of problem-solving strategies. It is not an exhaustive list, but it could include a visual representation, creating a systematic list, forming an equation, using a bar model, using trial and improvement, working backwards, and so on. Learners should become increasingly independent in recognising and applying the underlying mathematical structures and ideas within a problem in order to devise and implement a plan to solve it. Logical reasoning is about explaining, justifying, and proving a solution. It is also about convincing others and adapting one's own thinking when listening to others or when comparing solutions. Reasoning is central to mathematics and forms the foundations of mathematical thinking. Justifications and proof should become increasingly abstract, moving from verbal explanations, visual or concrete representations to abstract representations including symbols and conventions. Fluency is not about speed. It's about performing calculations flexibly, efficiently and accurately. Fluency should be built on conceptual understanding, and as learners experience increasingly complex concepts and relationships, fluency in remembering facts, relationships, and techniques should grow, meaning that facts, relationships, and techniques learned previously should become firmly established, memorable, and usable. There is a general consensus internationally on what content should be included when teaching mathematics, but not on how it should be taught. We believe that by teaching through these 5 proficiencies, teachers across Wales will focus on the how as well as the what. Solving problems and reasoning should be part of the content and not treated as a separate add-on. Teaching tricks for short-term gain should be avoided, and mathematics and numeracy should be taught in a sustainable way that prepares learners for real life. Teachers should support productive struggle in learning mathematics in order to encourage learners that accept challenge, apply effort, and see mathematics as something that is useful and worthwhile. Alongside the mathematical proficiencies, this should help to ensure a student-centred curriculum where the learners are doing the majority of the work.